Hi, everyone. In this video, we're going to get a little more experience with working with factorials. So we're going to see some of the properties. We're going to see easier ways to work with them besides computing with these astronomically large numbers and things like that. So our first property is that factorials are what's called recursive. And so what that means is n factorial is equal to n times n minus 1 factorial. Okay, and to see this more concretely, notice 5 factorial is, just by definition, is 5 times 4 times 3 times 2 times 1. But what do we have right here? If we just separate off this 5, if we separate that, then right here, we've got 4 times 3 times 2 times 1. And that's the same, just by definition, as 4 factorial. And so we can do this with any number. So if we did 11 factorial, that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's hopefully the last time I will ever write that all out again, but maybe not. Then if we just separate off this 11, then right here, we've got 10 factorial. So that's 11 times 10 factorial. And then we can keep doing that. What we can do is we can cut this off wherever we want. So if I want to cut it off after the 8, then I can do that. Because if I cut it off after the 8, then what do I have right here? I have 7 factorial. And so 11 factorial is also equal to 11 times 10 times 9 times 8. And if I'm done, I want to cut it off here, then I can do that. I just stick a 7 factorial. Because whenever you stop, then the next number has all the other numbers multiplied after it. And so by definition, that's that number's factorial. So if I stop after the, say, the 8, then I've got 7 times 6 times 5 all the way down to 1, and that is 7 factorial. And this is really useful when we're computing permutations. And so if I wanted to do 34 permute 3, then, well, I'm not going to write out 34 factorial. That's 34 factorial over 34 minus 1, or minus 3 factorial. I don't want to write out 34 times 33 times 32 times 31 times 30 times 29 times 28, etc. That's going to take me forever, and it's going to take me even longer to actually do. And not to mention that 34 factorial is crazy. 34 factorial is approximately equal to 2.95 times 10 to the 38th power. That's a 295 with 36 zeros after it. It's an astronomically huge number. And so for larger factorials, calculators can't give the exact answer because the numbers are so large. And so to remedy this, we don't want to work with the full factorials. We want to use this property to be a little cleverer about it. And so what we can do is, well, 34 minus 3 is 31. So this is 34 factorial divided by 31 factorial. And now we can expand, we can cancel. We know that there's a 31 factorial hiding inside this 34 factorial, right? Because the 34 factorial is 34 times 33 times 32. And then we multiply, we can cut it off here, and then we stick the 31 factorial right there. Because if we were to continue writing it out, it would be 31 times 30 times 29 times 28, all the way down, times 3 times 2 times 1. And so we divide by 31 factorial. And so here we're multiplying by 31 factorial, we're dividing by 31 factorial. And so these 31 factorials, they're numbers, they cancel. And we're left with 34 times 33 times 32, which is still a big number, but the calculator can handle it just fine. And it's 35,904. Okay, and so in this video, we're just going to keep practicing with these sorts of factorial identities. Okay, so as an example, let's do 9 factorial times 4 factorial over, let's say, 5 factorial. So what I'm going to do is I'm going to write out 9. What I want to do, I want to simplify this. What I can do is I notice 9 is bigger than 5. And so when I start writing out the 9 factorial, I'm going to do 9, 8, 7, 6, 5. And once I start writing that out, I'll have a 5 factorial. So I want to cancel the 5 factorial in the denominator. And so the way to do that is I'm going to write 9 times 8 times 7 times 6 times 5 factorial. And then we still have this 4 factorial up here, divided by 5 factorial. And I can cancel 5 factorial with 5 factorial. And I'll get 9 times 8 times 7 times 6 times this 4 factorial, which is 4 times 3 times 2 times 1. And so what we get is 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1, which is 72,576. Let's look at another example. So this next example, let's do 8 factorial divided by 3 factorial times 5 factorial. So again, we want to cancel everything in the denominator. And so what we're going to do is, so we're going to want to cancel in the denominator, and we're going to want to start with the largest thing first. Starting with the largest terms first. Okay, and so this 5 factorial is going to be the largest term. And so we'll expand the 8 factorial in the numerator. And so we'll get 8 times 7 times 6 times 5. And if I cut it off here with a 5 factorial, I can cancel the 5 factorial in the denominator. And so when I do that, cancel, I'm left with 8 times 7 times 6, no factorial because we canceled it, divided by this 3 factorial, which I'll expand as 3 times 2 times 1. Okay, and so now not everything is fully canceled, but I can get rid of this 1 because multiplying by 1 doesn't change anything. And I notice, okay, I can divide this 6 by this 3. And so when I cancel that, when I do 6 divided by 3, I'll replace it with a 2. So the 6 is gone. And now I can divide the 2 by this 2. And I'm left with 8 times 7, which is 56. Okay, and so the reason this works is because 6 is equal to 3 times 2. And so if I cancel the 3, and then I'm left 3 times 2 divided by 3 is just 2. And so I only have a 2 left. And then if I divide by 2 again, the 2 goes away. Let's do one more example. So let's do 70 factorial divided by 68 factorial times 4 factorial. Okay, and so here, again, you kind of have to do the this sort of technique. You have to manipulate the factorials because 70 factorial If you wanted to just plug all of these numbers into a calculator, it won't work. 70 factorial is too big for most calculators. If I use this on my calculator now, okay, it's actually doesn't give an error, but 70 factorial is too big for many calculators. It will give you an overflow error. It's just too much. A calculator can't do it. And so what we have to do is we want to cancel the biggest term in the denominator first. So we want to cancel the 68 factorial in the denominator. Well, we can do that because we have a 70 factorial up top. And so if we write 70 factorial is equal to 70 times 69 times 68 factorial, we're stopping it after 68 and then just adding a factorial. Then we're dividing by 68 factorial times 4 factorial. Then the 68 factorials cancel. And if we expand this 4 factorial, we'll get 70 times 69 divided by 4 times 3 times 2 times 1. Okay, so now, again, I'm going to get rid of the 1. And so what we have here is we can start canceling each of these one at a time. So if I cancel this 2, I know the 70 is divisible by 2. And so if I do 70 over 2, I'll cancel both. And then I'll be left with a 35. So this is equal to 35 times 69 over 4 times 3. Now 69 is also divisible by 3. So if I do that, I'll be left with a 23. So this is equal to 35 times 23 divided by 4. Now, this is pretty much as far as we can go with this manipulation because 35 times 23 is not divisible by 4. And so if I just put this into my calculator, 35 times 23 equals divided by 4, we're going to get 201.25. Now, if you were to just calculate all of these quantities individually in your calculator, if I try that now, so 70 factorial divided by 68 factorial times 4 factorial, depending on your calculator, it might need to round, and it in fact does round and doesn't give me quite the right answer. So these manipulations are really the only way to go. Okay, hopefully that gives you a better feel for how to work with factorials. We'll be needing that for permutations, and then the next thing, the next formula, which also will use these factorials. And so you really need to make sure you're comfortable with manipulating them in this way. That's all for this video.